Hi, everybody. Okay, so getting started a little late or early today. Actually went pretty far down a rabbit hole just now, which sort of caused this delay, which is amusing because this is something I wanted to circle back and talk about. And as I was mentioning with discussing with Taylor earlier tonight, what we were finding is I actually tend to follow these things uh, pretty regularly. And so I wanted to talk about the avoid racing to the end again, because in my rush to get to the end, I guess, I actually forgot something that I think is super important to share. And that higher order bit is one of and maybe I touched on this a little bit, but I want to discuss it in a little bit more detail. And it's this idea that when you race to the end, oftentimes you are shortchanging yourself. And what I mean by this is, again, if you become so outcome oriented that the only thing you focus on is getting something done so you can have the check mark next to it, what I find is for simple tasks, no big deal. Empty the dishwasher, that's fine. Run to the grocery store, again, not a big deal. But when you're trying to do something like learn machine learning or learn machine programming or become an expert in software development, and you race to the end with your tasks, you are often just shortchanging yourself. That this is my strong conviction. And I'm quite nervous about this, to be honest, with the code assistants that we have today. And that I'm worried that a lot of people are just trying to get the answer. And they're not necessarily worried about how they're getting that answer, where that answer is coming from, and the ramifications of just getting the answer. Now, I want to be clear, I'm not talking about being afraid of things like calculators. Okay, I'm not saying that, oh, don't use calculators because you're going to forget how to do math. No, I think that you learn basic arithmetic and you learn how to do long division and all that, and then you can use a calculator essentially to help you get there. And likewise, I think using coding assistants in the right context can be very valuable. However, there's a major difference between using a calculator and a code assistant. And then a calculator, you kind of already have to know the math that you need to do to plug it into the calculator to get the answer. You need to know that you're going to do this x to this y power. And so you understand that you're doing essentially exponentiation and that you're just having the calculator do it for you. Whereas with code assistants, it can often be that you are asking them essentially to think for you. That you're saying, hey, I want to do this thing and figure out how it should be done. Figure out all these details. And again, if you're just doing a prototype, you're just trying to like tease out if high order idea will work, try to build scaffolding code for you, totally fine. But if you don't understand the basics of things, which is what we're going to talk about in this podcast, this racing to the end, I think, can really hurt you, because what I've seen happen is that people that are racing to the end because they're just concerned about the short-term productivity boost will oftentimes never deeply learn how to master a skill, and then they will end up being beholden to subpar solutions. For example, I know a lot of programmers that learned essentially the easiest language that they could learn and then stopped there. So in today's era, maybe that's Python or JavaScript. And I don't mean any disrespect to those languages. I think both of those languages are super valuable in the right context. However, I think there's a reason why a large number of programmers program in Python and JavaScript. And at least initially, it's because I would like to make the conjecture that they're easy languages to learn. In that, I often make the joke that Python code writes itself. When I was learning Python 20 years ago, something like that, almost 20 years ago, I bought a Python book and I read a little bit of the Python book, but Python basically just wrote itself, and everything that I basically was trying to do, I was working on transforming some compiler output on basic blocks or something into some other format. I think it was like a conversion from out of order instruction set architectures to in order instruction set architectures for, I forget what it's called now, but it's like vector instructions, where you basically have wide, long channels for compute, that rather than doing essentially many out of order instructions that can be done like speculatively, you instead do things that are in order, but you try to do like multiple things at once. And so it's a different approach. And this is different than like the GPU SIMD thing, where SIMD is usually, single instruction, multiple data, right? So it's the same instruction with different data. Whereas this in order it could be different types of instructions, different data, that kind of thing. Anyway, the point of this is I had never programmed in Python before. I picked up the Python book. I really didn't have to read it. It just kind of wrote its code for me. Now, what I think is dangerous here is that if the goal is to become an expert software developer, I think just being able to kind of dabble in Python or JavaScript is not likely going to get you to be an expert. However, if you focus on what I think is happening in a lot of the world today, which is sort of the TikTok era of 30-second attention span, you may be compelled by the code assistants, which are going to help you solve things. And similarly, before code assistants, it might have been Stack Overflow, but I think Stack Overflow is like a little bit different in that you still have to articulate the question properly, and then the onus is sort of on you to read through the responses, and oftentimes the responses are not copy-paste code that will fit perfectly into the thing that you're working on. Maybe, but it's been my experience that not necessarily. But you also have to make a judgment call based on like the upvotes, right? And oftentimes there's many, and you can see details. And so I think you're still critically thinking. I think this becomes even more important when you have the language model systems that are trying to speak using very strong claims. And I can't remember if we've talked about strong claims, preferring weak claims to strong claims yet. It's in here somewhere. It's actually one of the core values that we have at Merle. Prefer, I think it's prefer weak. Yeah, did I miss it here? Introspective. It works. That is it's quite strange. Okay, now I'm super curious. I'm worried that maybe I was racing to the end. Maybe it's not in here because this is one of the core things that I teach at the beginning of the class, since I think it's such a critical piece that I actually have it as part of the curriculum. So maybe that's why I'm not seeing it here. Oh, no, there it is. Okay. Yes, preferring weak claim strong ones. So the weak claim example is what I just did. Is I was saying maybe the reason why it's not here is because I teach this throughout the course, but I didn't say. So that's a weak claim because I'm reducing the strength of that claim. And this often happens in scientific research quite a bit. So if you want to do a PhD and get publications, you often will need to use weaker claims. Otherwise, the people reviewing your paper, they can get real upset about this because science often prefers precision in claims, and strong claims like C++ is the best programming language in the world is like not necessarily true, very hard to properly quantify, and so you just don't say those things. Anyway, when we talk with humans, oftentimes humans are really good at making or they have the capability of using weak claims when they don't definitively know something, which can be super important. For example, when I talk about Rust, I'll start by saying, I don't really know Rust, so don't trust me. And I can sort of do pattern recognition on code analysis, but I don't really know what I'm talking about, so don't believe what I'm about to tell you. And this can be very helpful because then if I say something that's really stupid, which I probably do if I'm talking about Rust, then people are like, oh, yeah, but he said he doesn't know it, so yeah, we won't trust him. But if instead I come and I say, yeah, I'm an expert in Rust, and I start telling you all these things that are basically lies and nonsense, you might start to get very confused. You might actually start to doubt yourself and your understanding. So how is this relevant to what we were just talking about? Most of the code assistants that are out there tend to talk with strong claims. They tend to speak with a level of certainty that doesn't actually match the confidence level that they really have. I don't know why this seems to be happening. There's ways to actually provide a confidence score using things like adaptive Bayesian networks and other things that can do the analysis of the data that you've trained on and understand essentially the distribution of that data to then give you a confidence score of how much data you've trained on in this n-dimensional space to then qualify how confident it is based on the quantification of that data. Hopefully that makes sense. But just think of it as like a two-dimensional plane, X and Y, and 4 quadrants. And imagine if all of the data that you trained on is in the lower left quadrant. It's down. I don't know if my camera's reversed here, but it's down over here. And that's the only data that you train on for the system. Well, maybe the best that you can say then is you're like going to have a 25% confidence, because what about the other 3 quadrants that you haven't seen any data for those spaces? This is what you can do with things like naive Bayes or Bayesian networks and other techniques that can give you confidence scores before it gives you classification or prediction, things of that nature, so you truly understand sort of how confident it really is. So the point I'm trying to make is these code assistants can speak with strong claims and oftentimes be so compelling, especially when you're not an expert in something, that you could turn your brain off. And that's where I think the danger lies. Again, different from a calculator, because a calculator, it's like you still kind of have to understand what you're trying to do. And then it's just helping you with the long division. And I do think that there's a certain point of minutia where if you're really good at something, like, do you really need to write another file parser when you get the concepts? Yeah, maybe not. Like, I've probably written hundreds of file parsers. I don't know that I need to code another one. And so if an AI wants to do it for me, like, yeah, absolutely. But if you take that experience away entirely from programmers, I'm not sure how much you're helping, especially long term. Okay, so this is all relevant in this higher order space of mastering the basics. This is something I think if you want to be truly exceptional in almost anything, you pick the domain, I would argue master the basics. More than trying to do the quadruple backflip spin move from the 50-foot high diving board or whatever, just try to master the simple stuff first. Just try to master doing a single backflip or a front flip or what have you. Then when you master those basic things, you can build on them. But if you haven't mastered the basics and you try to jump to the end, then what you often end up with is subpar solutions. So these things go kind of in tandem, is that if you just learn like sort of one way to do something, let's say the only type of iteration that you ever learned was a while loop, and you just stop with a while loop. That's it. It's the only type of iteration you've learned. Then everything, every kind of loop, every kind of iteration is a while loop. Okay, it doesn't sound so bad, right? Well, imagine if the only thing that you learn for iteration now is recursion. Okay, just pretend with me for a moment. So you don't learn normal iterative looping. You learn recursive looping. Now, this is essentially the same idea, except there are major downsides to recursion that will limit your ability to do things iteratively, or in a looping fashion, due to the way recursion works with respect to the call stack. And basically what that is that every time you have another recursive call to itself, you add another function to the call stack. And generally speaking, in almost any modern day computer that's, not a supercomputer, if you do iteration that many times, looping, whatever we want to call it, that many times using recursion, you'll more likely than not blow the call stack. If you try to do that like on an embedded system, you're pretty much cooked. So instead, what I think is like a far more, and yes, I drink a lot of liquids. Mostly I'm drinking a lot of caffeine tonight because I'm a little bit sleep deprived and I need the caffeine so I can keep going. So back to the recursion. So now imagine that you just learned recursion. You haven't mastered the basics, and you're following this. You're just racing to the end. Every time you need to loop, all you see is recursion. It's just recursion. Eventually, this is not going to work. You're going to work on an embedded system. It's not going to work. On top of that, let's say that you've been coding for so many years now, and you continue to kind of skate by with not really understanding things because you just kept trying to just do the short-term thing and get things done. Eventually, this is going to probably become the ceiling for you because you didn't spend time actually learning and growing. You were just racing to the end. And now something that's so simple, like iterative looping, with a for loop or a while loop or do while. I mean, not that I would recommend this, but even like Goju. I mean, Goju looping used to be a thing. Again, I'm not saying use Goju looping like bad, but back in the day, it was actually a legitimate way to do looping. So the point is, imagine you're a 10-year veteran in programming and you're trying to get this new job, and they're asking you to write basically some form of looping, and all you know is recursion. And they're like, well, that's not going to work. This is an embedded system. Just write like a typical loop. And you don't know how to do it. And you don't know how to do it, not because it's too complicated. It's because you were just racing to the end and you did not master the basics. And I see this hold people back in their careers over and over and over again. That they learn how to do something one way, and then they decide that's the only way they need to learn it, and then they become a dinosaur. And the truth is, I think, especially in the AI era, this is maybe it's becoming easier and easier to essentially make yourself obsolete, because you're having the AIs think for you. And the truth is, while the basic programming stuff is more likely than not, I think, going to be handled by the AIs, at least to some degree, the critical thinking component, I think that that's going to be required by humans for quite some time. So evolving your critical thinking skills, it can be extremely helpful. So in this podcast, what I really want to talk about is to go a little bit deeper on this, avoid racing to the end, and for basically the sole purpose of trying to help us realize that this can inhibit you greatly. And if you spend just a small amount of time each day, instead of just getting something done, but give yourself a moment to explore, kind of like what I was just doing before this, is we were going down this rabbit hole. I'll actually show you. We're going down this rabbit hole with Linux, and we were confused about Linux having this start date that actually seems to hit around 1970 and then goes up to 2038. And so I was actually reporting this bug to the team, basically saying, let's see if I click on this. I thought I could click on it. Okay, maybe I can't anymore. 18. Yeah, there we go. Okay, cool. Yeah. So about 2038. And so I was reporting this to the team, and the Merlians were international, and some of them are pretty crazy like I am. So a few of the team members responded immediately and said, oh, it's worse than this 2037 thing. It actually goes back to 1970. This is what one of our super coders, Valentin, was telling me. Valentin and Ashish. So if you guys are watching this, hey guys, thanks for the chat. And then what we start to explore is when Ashish mentioned the 1970 thing. Like at first, the 2038 thing didn't register with me at all. But when Ashish mentioned 1970, because I was saying, oh, Val and I were talking about how, oh, it jumps into the future. And that's strange. And then I was just going to let it lie. But then Ashish said, oh, but it also jumps into the past. And at first, when he said jumps in the past, I was thinking, well, it jumps to the past because that's what Mentor does. It looks at the past. But then I was looking at what he was saying, and he was saying that it's like 1970 in the past. Now, this is different than looking into the past for other systems like this one I'm looking at with the Denta OS, where it's looking into the past of 2015 because it was incepted in 2015. that's okay to look into that past. But over here, first, I'm pretty sure that Linux wasn't created in 1941. In fact, I don't even think that Linus was born at that point. But then this other one, 1970, really jumped out at me. And I started to think about this, felt like 1970, January 1st of 1970 seems like a very interesting date to me for some reason. So I started Googling this, and I think I was asking, what is the start date for Unix epoch time? It's January 1st, 1970. Then I was like, okay, what is the max date for the Unix time system? Because I remember that it was bound to the ranges of essentially like these 32-bit numbers or something. I think it was something like that, based off of seconds. I think it was seconds, or something like that. Yeah, I'm not entirely sure. I'm probably getting the unit slightly wrong. But we know 32-bit integers can only store 4.2 billion numbers, I think, unsigned, which is not going to cover the entire range of possible years. So then Google came back and told me, oh yeah, the upper bound for the date system is 2038. And then I went back to the team and said, yeah, Val, Ashish, guys, I think I know what's going on here. I think they're testing the bounds they're testing the lower bound for the date on Linux through Git to make sure that works. And then they're testing the upper bound. There's some other interesting artifacts in there that Val was pointing out, something about 2086 or something. And at that point, I really wanted to do this podcast, so I didn't go too far down that rabbit hole. But I wanted to share this with you as an example of how I follow my own advice, is that I really wanted to do this podcast because there's something in particular I want us to look at, which is one of these issues that we have in DentOS. But I got sidetracked as I was trying to look at something in Linux. But instead of racing to the end, I put the pause button on the podcast because this was potentially higher priority, as I thought that this was a defect in Mentor. What turned out is it's not. I don't think it is. I think the team thinks this is not a defect. What I think the team thinks is that this is somehow them hacking the Git system so that it will test the bounds of Git using Linux. And so maybe it's a thing for both Git and Linux testing the bounds, so then they can see that it'll work correctly for both of these timestamps. Like that part, I'm not sure on. But I do think that's probably what's going on. Now, how is this relevant to anything? The reason why this is relevant is because I avoided racing to the end, I now know more. And this is how I think you start to acquire an incredible amount of knowledge. Because when you apply this technique over and over and over on a daily basis, weekly, monthly, yearly, over decades, each of these small pieces of information starts to compound. Like, for example, when I was talking to the team, I was mentioning something special about January 1st, 1970. I can't put my finger on it, but this date sticks out to me. And truthfully, I don't know. Not when I was first looking at it. I don't know why this date is unusual to me. I just know that there's something special about that date. And so sure enough, it is. Like, this is the start time for our Unix date for their operating system. And this is the type of thing that I think really will set you apart from others. Like, if you really want to do truly incredible things, I think that just giving yourself time, just a small amount of time, every day, to rather than just racing to the end And again, this is just for the super important stuff. I'm clearly slamming the caffeine. I'm probably going to have to take a bio break here before too long. But this is, I think, one of the key benefits that you get when you avoid racing to the end. And I think that, at least for the people that I know that end up with massive amounts of knowledge, just obscene amounts of knowledge, people like Tim Matson or Smuff or Taylor Dolezal, these gentlemen, I think, end up knowing so much because in many cases, no matter how much they want to get something done, if they see something that's a curiosity to them, they literally will put the brakes on this thing just momentarily and look in this thing, or they'll take a mental note and say, okay, I'm in the middle of something, but I'm really curious about this, so I'm going to write this down, and then I'm going to look at it later. And so I think that this example with Linux is a real example that literally just happened before this podcast. And it dovetails very nicely into what we're actually going to talk about next. But maybe this gives you more concrete evidence of at least the philosophy that I follow and how I think that it's helped me tremendously. And again, what's very curious about this is on the surface, when you first start doing this, this actually will slow you down. It will make you slower, which can give you the false impression that you're wasting time. But what I found is that ultimately, when you do this over and over and over, like for example, the team seemed to be a little bit stumped on this Linux thing. Imagine if I'm not involved, how many hours or days or weeks might it have taken them to finally make the determination that, oh, what's going on here is they're testing the range of dates. But then I come in, and again, I'm not trying to toot my own horn, I'm just trying to show the benefits of this type of approach, is that I come in and I look at this and I say, no, there's something strange going on here. I've seen this before. And then within seconds, we can diagnose something that could potentially save the team, I don't know, weeks of diagnosing. Like they mentioned that, oh, this is a known issue. We're looking into it. No one seems to quite know what's causing it. This is the benefit of this type of thing, is that the savings long term can be ridiculous. I mean, you end up being able to, you're the Beatles, right? Is that you can create music and you can do things that other people simply cannot do because you've been applying this type of learning throughout your entire life. Okay, so I've sufficiently beaten that horse. And so now I want to actually get into the topic that I want to talk about. And this, again, was inspired by avoiding racing to the end and mastering the basics. And I'm really, really keen on mastering the basics. I can't emphasize this enough. Part of the reason why I think there's so much confusion in AI today, and people are making really bad decisions with their AI systems, is that people are trying to rush to the end, and they aren't understanding AI at all. And so we're ending up with a lot of really subpar systems. And for those people that are actually spending time mastering the basics, I think their deep understanding of AI is going to be a massive differentiator in the TikTok era that seems to be today, where people think that they can become a domain expert in something by studying it for 5 minutes. That just doesn't happen. It's just not possible. And so you should fight this urge. This is actually part of the reason why the Goju Tech Talk channel is, it just dawned on me that Goju Tech Talk actually sounds a little bit like Goju TikTok. And Man, that was not intended. So- oh, I hope I don't have to rename the channel. Anyway, part of the like the anti TikTok. It's like, yeah. Anyway, part of the inspiration for these episodes and the channel is to do long form, right? This is how I teach at the university. Is I could teach shorter classes. I refuse to. I won't do it. 2 hours. And the truth is, a lot of the students, it's too taxing for them. And then they don't take the class because it's just too much of a time commitment. And the truth is, like, I think that's good. Because if they're not, I think, in the mindset, and again, I'm not trying to be School of Hard Knocks, but I really don't follow that belief that anything worth learning can be done in a short period of time. I think that you really have to commit yourself to something and really lean in to get a level of excellence in it. And if students aren't interested in being able to really commit themselves to the lectures that are going to take some time, then they're probably really not going to like my class. And I'm probably not going to really like them as a student, because I tend to really resonate with people that care deeply about things and aren't just looking for getting an A and being able to show that they have an outstanding GPA, which serves very little purpose in life, aside from just being able to say that you had this whatever GPA. Okay, so taken holistically, we can now get to this next point. But before we do that, we're going to take one more minor detour. And that detour is, I wanted to quickly talk about the background music that's playing. So the background music that's playing is this gentleman, Raphael Weinroth Brown. And I stumbled across Raphael's music maybe like 3 years ago. As I think I mentioned in many of the earlier podcasts, I'm a huge lover of music. I'm a huge audiophile. I have so many different pairs of headphones, and yeah, if I have an addiction, it's listening to music. And I really do listen to stuff like this all day long. So anyway, I came across Raphael's stuff, and truthfully, my favorite instrument of the classical instruments is the cello. And one of my former partners was a classical violinist. Played in an orchestra. Just really talented. Violin's actually my second favorite instrument. Love it. It's amazing. But the reason why I like the cello a little bit more is it can be a bit deeper. It has a little bit more bass to it. Both, I think, are incredible string instruments. Anyway, so I listened to some of Raphael's stuff, and I fell in love with his music, and I reached out to him and told him about my deep appreciation. And I basically became quick friends with Raphael and let him know that, I have this company and I plan to do these various podcasts. Keep in mind, this was several years ago, but, in my mind, I'm kind of living in the future. And I thought, I'm going to want this at some point, so maybe we can start putting this together now. And so we commissioned Raphael to do a couple segments. You're hearing one of them right now. I may play the other one in a subsequent podcast. The other one has a little bit more of the higher pitched, more treble based cello, but incredible. The only reason why I'm a little hesitant to play it is it's so captivating. I have a sneaking suspicion everyone is going to check out from the studying and learning of technology that we're trying to do on this channel, and instead just pay attention to Raphael. And no disrespect, I do the same thing. In fact, when I listen to the other track, I get so distracted by how amazing he is. I sometimes forget, like, oh, right, I was supposed to be doing work. But anyway, as I was commissioning Raphael for this, we made an agreement with him that Merle would pay for his services. He would essentially record these novel pieces of music, and we would get access to them in perpetuity, but he would retain the rights. So he can then use them for any of his albums. So we're trying to support the musicians and the amazing people like Raphael. And my hope is we will commission him for future work. And maybe at some point, if we have like some kind of awesome party, we'll fly him in. I think he's in Canada. Yeah, he's Canadian. And we can meet him in person and just absolutely love this guy. But what I also told him is that when we start using his music, I would try to call him out directly so people would be aware of him being the mastermind behind not just playing the music, but he wrote this, which is incredible, that he isn't just sort of playing someone else's music. He's actually doing, I think, in some ways similar to what we do at Merle, is we are not just using other people's AI models. We're actually inventing new ML methods and then building those for our system. So I have huge amounts of love for Raphael. His music is incredible. And if you're interested, you like this, definitely follow him on Instagram. I think I follow him on Insta, and I think I'm following on YouTube as well. And his stuff is just incredible. The one that I think is really great is this Tumult 2, I think, was also just really fantastic. For some reason, I think that one really stands out. Okay, cool. So now we can actually get to the topic at hand, which is this system here. We're going to look at Dent OS, and Dent OS is a pretty good repo. Mentor gives it a pretty good score. And I was just flipping through the repositories and stumbled across this one. And I thought I would talk about these to show a couple interesting points. The first point that I think is fascinating with Mentor, or at least we find this to be really helpful, is Mentor, I mentioned this in an earlier podcast, Mentor will often categorize pieces of code that have a similar sort of semantics in the same body. It'll group them together in a same sort of cluster, k-means clustering kind of thing. And what's interesting about this is you can kind of think of it as like this regular expression solver. So notice how 3, 2, 4, and 1 are different in all of these cases, yet they're still being grouped together. And there's other cases that I've seen it do this as well. Like, looks like in these cases that they're the same, but you can imagine that this generalizes. But what I think is pretty cool about this, in addition to the fact that it's doing essentially the regular expression alignment, is that it's figuring out the actual structure of the regular expression on its own. So you could certainly write a regular expression yourself that could search all the code once you see this and say, present bit and then you'd be like any shift any blah blah blah, right? But being able to have an AI that can then figure this out and then also immediately say, look, there's a regular expression sort of pattern here. Find these anything else and just group them together. So now what you end up with is something that not only can learn these things in a general fashion, that will group things that are semantically similar, but syntactically different together. And that will help you, I think, identify things like copy-paste issues. My speculation is all of these lines are different on purpose, but I don't know. And minimally, I think that, yeah, I'd probably make a function for this. And then I would just pass in. It looks like the only thing that changes is just this, and I would just pass in. This appears to me to be like the number of bits that you're shifting to the left. So just create this as a function and just take a parameter that's the left shift number. That's sort of how I would do it. Okay, but that's not the actual issue that I wanted to talk about. I want to actually talk about this one, because this, I think, is a really good example of something that looks okay, looks safe, but it's a basic thing, and it's something that we can improve on with very little effort, but it will help us in a number of different ways. And it will often help us in ways where it potentially tease out other issues that may or may not exist in the code. And what I mean by this is, when I look at this, I don't immediately love this code. So I like that Mentor actually is calling this out and flagging it as something like, hey, I don't know, this is a bit unusual. And then Mentor is trying to rewrite this. And I looked at the different variants of what Mentor proposes to solve this. And I think they're all improvements. So this one, basically, it's just giving you these ranges. And by the way, this is something that I think is absolutely right, is when you look at this more closely, it's a range here, it's a range here, it's a range here. This one is potentially also a range, but it's only constrained in one direction. But is it, though? Right? We can get into that. Yeah, okay, so this one, yeah, you can see that it actually embeds the range. I must have missed that when I was just skimming it before. So Mentor is actually realizing, oh no, this is a range 2. It's just that you didn't specify the lower bound, which is what I was going to get to. But notice, though, one thing that's really interesting is it changed the number here. So this is 0 to 7. It's not 0 to 8. But notice, though, for the other ones, it didn't. Right? 16 to 23, 16 to 23, 32 to 39, 32 to 39. So why is it changing this? Well, as you know, you're all super smart, brilliant coders. It's because there's not consistency in the range checking for the first range. Is unlike all of the others that are using what I believe is ranges using mathematical inclusion. This one is using ranges that is mathematical exclusion, meaning it's checking to see if it is one integer outside of the upper bound. These are within the range of the lower and upper bound. So this is the fundamental difference. I think that mathematically it's like it's represented. This is just off the top of my head, so I may not be getting this exactly right, but it's like if you're saying x is it's 0 to 7. Okay. So that's saying, I think that this is saying this is inclusive of 0 and 7, or this to this. Yeah. This is exclusive of -1 and 8. Essentially, these things are saying the same thing. The difference is this is, and again, I'm just trying to remember this off the top of my head, so I might be getting this slightly wrong. Feel free to fact check me and put in the comments if I'm messing this up. But this one I think is saying it's a range, but be inclusive of the literal values on both sides. This one is saying it's also a range, but be exclusive of the lower and upper bound. And these are actual mathematical representations. So you see, if you see a range that uses the brackets, the square brackets in math, that's what this means. And if you see it using the parens, it means this. So this is not like Goju math. This is like true mathematics, like formal definition stuff. Okay. And this actually gets me to the point that I want to make is I think that we should make essentially these as functions that we're going to have it be something like is within range. And we're going to just say, maybe we'll say, I'm just kind of coming up with this off the top of my head. And then we'll say the value. Okay. So we're gonna start here. And then what I'm gonna do is I'm gonna take that code. Where's my counter here? Here we go. I have this OCD about how it's not the OCD of the comment. You guys know about that. It's the OCD of that it can't be longer than 80 characters. And this is not a screen width thing, because obviously the screen width can handle it. It's that the psychological studies that we've seen in studying the way people reason about things, specifically symbols, like in written language, it tends to be that humans are much better at scanning things in a vertical fashion, up and down, rather than a horizontal fashion. And this kind of makes sense if you think about humans having two eyes, is that we can see this space and we can just be on a fixed space and look up and down. Whereas if we go side to side, our eyes are not lined up like this. If our eyes were lined up like this, we might be better at this. But since they're lined up like this, we are better potentially looking up and down. At least that's potentially the argument. So the point is that this is one of the reasons why you don't necessarily want 500 column lines of code. It's not because the screen width doesn't support it. Clearly, there's much more screen real estate right here for me to include it. But it's that it actually makes the code easier for humans to reason about because of our ability to read vertically much easier than horizontally. And also, if you pick up any of your favorite books or look at your phone, yeah, we're doing the same thing. You may be asking yourself now, but what about movies then and TV? Well, that is actually following the same concept, and it is mirroring this idea. Again, two eyes that are aligned horizontally, which means we have a wider frame of vision. So we can see more this way. That's why the screen isn't like this. It's not longer. But with movies, it's a fixed space. So we're staring at the thing just directly. We're not scrolling up and down like we are with text. So I think actually both of these, at least the way that, in my head, it kind of makes sense that both of these are actually following sort of the same principle. But this is why at Merly, we still try to prefer stopping at around 80 characters. Although Admittedly, the engineering team doesn't really listen to me on this, so. But I'm old school, so I still do it. Okay, now I want to go back to the code that Mentor was showing, because I want to change this first before before I go too far down this rabbit hole. And part of the thing that I want to do to change it is to show why I think that there's like many levels of improvement for this code, at least in my mind. And even if I didn't make this a function, there's a way to write this that I think is easier than the way that it's written. And again, this is a very small thing. So it may feel like, why are we spending so much time on this? Like there's so many other more important things that we can learn. This goes back to mastering the basics. Because when you really master the basics, you are mastering everything. And I tend to find that it's the people that don't master the basics, they're the ones that end up not really understanding what they're doing, right? It's like when we were talking about that Boolean expression in React Native, and I was explaining how all these parens are causing reordering of the execution of things, and then the mutating operations are changing the state of the program, and you can have short-circuited logic based on the ands and the ors. Those are all basic things that if you don't have a super strong mastery of the basics, then you likely won't know how this works. And so once you master the basics, you basically become the master of almost everything. It's just oftentimes, I think programmers in particular like want to play with like the shiny new toy. But if you try to do like, let's say, template metaprogramming, but you don't understand things like operator overloading, you probably won't even get the value of template metaprogramming, because you won't understand that you can overload operators for the different types of objects that you pass in, which is one of the keys to, being able to generalize things and harnessing the true power of templates. Again, basic stuff, because operator overloading is one of the key techniques to ensure that this general template function or behavior then specializes. It creates different types of behavior for all the different types they pass it to. So you can't just jump to, I guess what I'm saying, you can't just jump to book 12 in becoming a wizard and think that that's all you need to read. Like that's not any way to be a wizard. The true wizards, like Urs Muff or Tim Matson, these guys all master the basics. They know the basics forwards and backwards, and it's because of that that they can do things that I think the rest of us mere mortals can't. And so we focus on things like this because once you start to really see the beauty and the elegance of these simple things, the rest of this stuff just automatically simplifies itself. So what am I talking about? Well, in this case, let's look at this, the way that they framed this expression. Okay, we'll just take something as simple as this. Yeah, this is why I was saying I use the text editors, because it's just, yeah, Visual Studio is just trying so hard to help me. That's actually making me slower. Yeah, I find it quite annoying, actually. Okay, so let's change these to just be value. And so now we have something that sort of would compile-ish. And let's change these to lower and upper, okay? And now we're actually doing sort of what we're meaning to do here, right? Okay. So if Yeah, if our value is greater than or equal to lower and value is less than or equal to upper. Now, the reason why I don't like this is what I really like, and I think Python does this, is I like things that kind of look like this. Lower is less than value is less than upper. And the reason why I like this is it puts, I think, in our mind something like this. 7 is less than x is less than 13. And you read it from left to right. Okay? But this doesn't follow this structure. And the reason why it doesn't is that it doesn't go from lower to value to upper. But we can make it do that, right? We can say this. If lower is less than value, less than or equal to value, and value is less than or equal to upper, I think that we've just done it. And now, then we'll say return true. Oh, please, seriously, this text editor. Yes, I know it's doing the scope for me. And I know there's a way to turn this off. It's just like, man, you're trying too hard. Okay, and now this very simple thing, this very simple change, I think makes this is the first piece that makes this easier to read because it matches the intuition of lower is less than or equal to value is less than or equal to upper. It follows in the line of thinking that we would want to reason about if we were thinking about it being constrained within bounds. And so my belief is, and this is a belief, I don't have the empirical data that shows this, is that someone coming in looking at this code, they would immediately say, oh, this is a range, this is a bounds here. Because they would see, oh, lower is less than or equal to value, and value is less than or equal to upper. Right? Again, it also simplifies the math because the mathematical operators stay the same. They don't change. Whereas the original, they are changing. It's saying it's greater than or equal to this, or it's less than or equal to this. More mental tax. Again, the goal of writing code, at least in my mind, is not to write something that's correct. The goal of writing code, at least in my mind, is to make sure the future developers that are going to look at this code make their life easier. And again, this is a very simple change. This isn't rocket science, right? Like, we're not doing that much to this code. We're just simplifying the usage here so it uses a consistent operator. That operator is less than or equal to, and it does it in both cases. And you could even change the name of this. You could say is within range and say this is inclusive, right? Based on the operators that we had, say we can say is within a range of lower to upper using mathematical inclusion. And then we'll say these things. Cool. And we could create another function that is mathematical exclusion. We'll get to that in a second. Okay, so this is the first change that we're going to make. And we can just use this, and then we can say this. Okay, we could also do this. Okay, so if the lower is less than or equal to value, and value is less than or equal to upper, then we're saying this is within this range, return true. And then we can say else, return false. Okay, now the first optimization that we probably all just saw is you don't have to do the else. You can actually just do the return false. Sure. But another optimization that you can do is you can just return basically this. Just return that. Because this is basically telling us what the answer is. If this is true, then this is within the range. And if this is false, it's not. So we can actually get rid of the if entirely. And so the first optimization was we elided away the else. The second optimization is we elide away the if. I mean, the if is still basically there. It's just an implicit conditional. And the result of that conditional is just being returned directly. Cool. So now it's basically just one line of code. Okay. Now, if we wanted to go like a little bit further, we could do this we were just talking about within range exclusive, and we'll say int const lower, int const upper, int const value. And we could, if we wanted to, we're obviously not going to do this, but could say this. Okay. Now, why do we not necessarily like this? Well, we don't like this basically because this is like copy-pasted code, and is that really the best that we can do? I don't know. I feel like we can do better than that. Oh, and we are gonna do a copy-paste on the comment, just to reference the mathematics that we have of using the exclusive range. Okay. But now what we're going to do is we're going to look at these two and we're going to say, can we make this like slightly better than just actually embedding these Booleans? And I think that the general rule in C++ is there's a preference for the less than operator. You see this in things like stood set and things that are using any sort of binary tree under the hood. I think that switches will also do this. Okay, so we're going to change this now, and we're going to say, what is that like dot thing? We're going to say this one first, right? Because we're going to say the exclusive one is the one that we want to keep because we somehow decided in C++ that we prefer the less than operator. So then what we're going to do here is we're going to rewrite this to then just call this other one, is within range exclusive. And now the parameters are going to be lower and upper and value. Okay, but this one was inclusive and this other one is exclusive, meaning that this is going to include one more number essentially on both ends. So let's just see an example of this so we can get it in our head. Clearly, I still can't type. The first example is with the exclusive, it would be -1 to 8, I think was the example. And then the next one is 0 to 7. Okay, so if you were to call the exclusive version, then you would call it like is within range exclusive -1, 8, and I don't know, we'll just say 5. And if you call the other one, you're saying is within range inclusive, and you're saying 0 to 7 to 5. Okay, so now we see like the difference. And so what this basically means is that we're implementing the inclusive one. And so the inclusive one is going to call exclusive. Exclusive is essentially expanding the constraints. So all we're going to do is just say lower -1 and upper +1. Yeah, maybe we'll just do it like this. I always get actually quite hung up on how to do the spacing for things as simple as -1 and +1. Yeah. So little things in life, right? Okay. So now let's just do just a simple test here. We'll say int const lower equals, let's try this, 0. Okay, we'll be lazy. To 7, and then we'll have this one just be value equals 5. And now we're going to do stood cout result of is within, this is going to be the range inclusive of lower, upper, and value. Right? And we'll do stood endl. And do we include IOStream? We do. That's good. Okay. And we're going to leave this comment in here. All right. I don't have my... Oh, do I have my keyword mapped? Oh, yeah, I do. Okay. All right. So we're going to try to build this. And this built okay. And by the way, on my Kinesis keyboard, this new one, it doesn't have function keys. I was trying to figure out the function keys earlier tonight, and I couldn't figure it out, so I have to use the mouse for these things. But I'm aware of the control F5 to run this, but until maybe by the next podcast, I'll have learned what that is. I did actually try to learn it, just so you know, and I ended up totally bricking the keyboard for a moment. Okay, so we're going to run this, and we see that the result is 1, basically saying, yeah, it's within the range. And so is within range inclusive seemed to work. But now we really need to test the bounds, right? So we kind of knew that either way, as long as we did the basic math, we would be right. But we really need to check that the lower and upper are working correctly, because that's the part we might have accidentally made wrong. So the inclusive, since we're calling inclusive, right? It should be 0, should work. Okay. And then just out of laziness, I'm just going to do result for 0, result for 7. And don't do copy-pasted code like I just did. Maybe I'll get the urge to be hyper pedantic and actually fix this. Okay, so we've got our values. We just rebuilt it. So now we're going to see what the result for 0 is, what the result for 7 is, pass value. Now, if we did this right, we should get true for both of these, right? And so we do. We get true for both of them. Okay, that's great. Now, just to test the exclusive, then what we want to do here actually before we do that, let's actually show that this does not work for this, right? Is that we're gonna do the inclusive, right? So inclusive should only go 0 to 7. So if we give it -1 to 8, this should give us false for both of these if we did this right. Okay, so we just built this. Let's run this, and we get false. Okay, cool. That's what we wanted. Now we know that the bounds are working correctly for inclusive. So now let's, we could just change this to exclusive, and we know sort of by default, because it's a tighter bounds, that these will be false, but we'll just go ahead and run it anyway, just to see that it's going to give us zeros, and it gives us zeros. Okay, so no big deal. Now the one that's more interesting is when we do this, is that now we're calling exclusive, not inclusive, which means these values that are outside of the constraints should not work. This should still give us false in terms of mathematical range exclusion. Okay, so let's run this now and see if we get false for both of these. That's what we should get. Okay, oh, whoops. Okay, sorry, that the pedantic person in me, I didn't change that. Let's run this one more time just so we can see that this gives us false for both 0 and 7, which is what we want for exclusion because those are not included. Okay, but now if we pass in the values 1 and 6, this should work because 1 is 1 larger than 0 for the lower bound, and 6 is 1 smaller than the upper bound for exclusion. So this should give us true for both of these cases. Again, if we coded this right. And it does. Okay, excellent. So now we want to go back to, we've kind of demonstrated that this worked. Now we want to go back to the original code and look at what they were checking and just kind of show that we can, the copy paste functionality in Mentor is still something we're working on getting right. Okay, there we go. And I know I can do Alt Tab it. I just am worried that Windows was gonna do something, was gonna not do the right thing. Okay, so now if I want to replicate this, let's actually do what Mentor did before, which is give these proper bounds. So we'll say int const lower 1. This is kind of a bad name, but let's just go with it anyway. Let's say that we want to, since they're using the inclusive essentially for all these. Actually, let's do it the way that they're doing it. So this one they're doing exclusive. So that means that lower 1, the exclusion would be -1, and then the upper 1 would be 8, right? That's the exclusive. Then the lower 2 would be 16, and the upper 2 would be 23. That's inclusive. And then the lower 3 is 32. The lower 4, sorry, upper 3 is 39. And then the lower 4 is 48. The lower, sorry, I keep getting this wrong. Upper 4 equals 55. Okay, and so we would say if is within range, the first one is exclusive. And so we want to be lower 1, upper 1, and we'll just be lazy and just say value. Okay, and we'll just say, okay, result 1. We get real wacky here. Okay, I'm going to do it. Value 1. 2. Let's just make this like all work. And then as an exercise, after, if people want to, you can put in other things and just kind of test the bounds. But in this particular case, let's just make it all work out of interest for time, and that it's 3:20 a.m. now, and the Coke Zero is building up in my bladder as I drink more Coke Zero. Okay, So now is within range inclusive. This is going to be lower 2, upper 2, value 2. Bool result 3 equals is within range inclusive. Am I not learning? Okay. Lower 3, upper 3, value 3. Yep. And then bool result 4 is equal to is within. And I think we can do this like control space or something. Yeah, like I'm aware of these shortcuts. I just I'm trying to do the actual typing process, so I don't get to I don't start pulling up the speed typing wackiness that confuses people. And so now we basically just do our C out again and say is true, or let's just say is within ranges, and then we're just going to say, just to make things fun, result 1 and result 2 and result 3 and result 4. And mostly this is stood. It doesn't like this. It doesn't like this because I'm not forcing this into a bool. What is it saying here? Could not determine which. Oh, at stood. Oh, okay. Like, do you just want this as me to do this? Is that your issue? Okay, whatever. Yeah. Okay. And so our result is true. Okay, yeah. So 1, 17, 33, 49 is within all of the ranges. And, you know, we knew that it was. And just for kicks, let's change this to 0. Oh, 0 is valid. My bad. -1 won't be valid because that one's exclusive. So this actually should fail. And it does. We get a 0 now, which is great. And now let's just change this back to 0. We should get true again. And we do, which is awesome. And now let's just test one of the exclusive ones. Sorry, the inclusive ones. And the inclusive one, we change this to 15. So 15 is outside of the inclusive range of 16. This should give us false. And it does. Okay, cool. So the thing that we learned here that I think is really nice is, one, now if there's a bug in our code, it's basically one line. That's a bug. Then we can add all of these checks, and we can make this shorter too. Like we could just say within range, but we added the exclusive, inclusive, just to be more mathematically precise, because there are actually different things as mathematical operators. But what I really like about this is that this prevents the chance that we could potentially fat finger this, right? That first of all, this is a strange confusion in my mind. This is unnecessary confusion that we might be adding to someone that's not understanding that we're actually doing an upper and lower bound check here, but we're not doing inclusive ranges like we are here. This one's exclusive. That's not super great. Also, we can fat finger these. We could accidentally drop something, and you can tell there is some fat fingering going on, because notice the spaces between these operators here is consistent, but then in this one that was added maybe later, there is no space after the operator and between the literal, which indicates to me that, I don't know, right? On top of that, what about these guys here? So this one is using inclusive and exclusive at the same time. What about this one here? So like this is inclusive and exclusive, inclusive and exclusive, inclusive and inclusive. Is that a mistake? Right? What about this over here? Right? So you're opening up a potential can of worms that I don't know that you need to. I think you can be very precise in your code and then take something like this that could be confuse a lot of people simply because of the lack of consistency of the mathematical operators and the implicit range check on like the 0 here, 0 to 7, exclusive. And then also the connections here, this can all follow the same call. And then once people see that these are all the same ranges, it becomes very obvious that they're all range checks, right? Like right now, when we look at this may not be clear that all of these are range checks. But then when we look at this code over here, we can see these are all range checks because it says they're range checks. And so if you can name things that are semantically meaningful, I think you should. And I think that that's going to likely make you a better programmer. It's going to help you master the basics so you'll understand how to do things like define this properly in a way that uses uniformity in the operators. So now, on top of that, if for any object type, you could templatize this, right? Like we could actually go and say template type name T, and then we can get rid of this. We can say this and this and this. And now, let's see. Yep. So that built. And then we can go, yeah, what the heck? Let's change this to this, this, and this. Let's try to build this again. Okay, let's just try to run this. Okay, so it's given us 0. Was that the intended? Yeah, because we changed this to 15. Let's change this back to 16. Whoops. Let's rerun this. Okay, we're getting true. And now check this out. We just created these template functions now, and this should work now for ranges for any type as long as that type implements the less than operator. We just basically did a form of template programming where we started with something very concrete. We then massaged the code to make it work in a more modular fashion. We followed the core principles of proper mathematics to have it do ranges that are inclusive and exclusive. We implemented inclusion as a form of exclusion without re-implementing the inclusive or exclusive operator. We just piggybacked on it. And the whole implementation leverages a single operator that can be overloaded for any class that is being used in the system. And on top of that, that operator happens to be the operator that is most commonly required for use of the standard template library. Boom. Pretty cool. Or I think it's pretty cool. Okay, so that's our lesson for the evening. I hope that was as fun for you as it was for me. And I think that going back, the two things that I think are paramount in this is this hopefully gives us a concrete example of the benefits of when we don't race to the end, that we weren't trying to just be done with this. We were trying to figure out how to do this more elegantly. And in the process, we ended up with something that, I mean, I don't know if all of you knew that it was going to go this way. Truth is, I didn't. I actually just went with this as we were going further. I'll be honest though, there is one hiccup with this that makes it a bit unusual, which I can leave as sort of an open-end question, is while this does just require the less than operator, this implementation now with this requires -1. So it may actually require us to rethink the implementation for inclusive ranges to use the less than or equal operator. Now, this is a very complex semantic question that I wouldn't say we can make a definitive decision about, at least off the top of our heads. We would need some time to properly think about this. And so let's leave that as a topic potentially for next time. Okay. Hope everybody has a great weekend.